All right, good people, let's do question 5 now. They say that the graph of f of x is equals to ax squared plus bx plus c, and that's g of x negative 4 over x minus 3 plus 8. We can already tell a lot of things from just this equation alone. We know that the equation of the vertical asymptote would be x equals to 3, and of the horizontal asymptote would be y equals to 8, right? From this equation alone, we can also find the equation of the axis of symmetry with the positive and with the negative gradient. There's a lot of things that we can just take up from this equation alone, right? P is a turning point of F, right? Here it is a turning point of F, and the point of intersection of the asymptotes of G, right? So this P value, it's the turning point of F, and it's also the point of intersection of the asymptotes of G. Because we have this equation, we can already give the coordinates of this point. Right, let's start there. We know that the equation of the asymptote of this graph, the asymptotes would be x equals to 3 and y equals to 8. So this would be the coordinates of P. 3 is to 8. So the coordinates of P would be 3 is to 8. Right? Can you see how I'm transferring information from the statement into my diagram before I even answer the question? Right? They say that we are given the point of intersection here, D, 5 is to 6, right? M and T are what? Are x-intercepts of F and G respectively. Here is M, you see it's the x-intercept of F, T is the x-intercept of G, right? So let's look at the first question, right? That's 5.1. Find the range of, the domain of G, right? So the domain of this hyperbola, it's gonna be x is an element of all real numbers. However, x cannot be equals to the x value at the asymptote, which is 3. X cannot be 3, that would be your domain. So 5.2, write down the range of f. So the range of f is what? It's the vertical existence. As you can see, the graph is existing from here going down and down, right? So from this value going down, the graph is existing. But if I go up, you see this graph does not exist if I go above that point. So the graph exists from this value, this y value moving down. So y is less than or equals to 8. So that would be the range. So y is less or equals to 8. 5.3.1, right? Determine the values of x for which f of x is bigger or equals to g at x. So first things first, when you answer this question, right, go find the values where they are equal. That's the first things first. So they are equal here, right? So from this point, they are equal, right? Then ask yourself, if I move to the right of this point, what happens? If I move to the right of this point, you see that, let me use different colors to show the different graphs now. Let's reduce the size a little bit. Let's use red to indicate this hyperbola. This is the red graph, right? So if I go to the right of this point, the red graph is above the black one, right? So that won't be part of our solution. We are looking at points where we are looking for points whereby the black is above the red, right? Where the parabola is above the hyperbola, right? So, but when I go to the left of this point, you see the black graph is above now. It's above the red one, right? So the black one is there, the red one is there. So that would be part of our solution. This happens from this point till that point, right? If I go, then I ask myself, right? Let's indicate those 2 points where my solution exists. This point and that point, my solution exists, right? But then when I go further to the left of P, does my solution still exist there, right? Let's see. If I go to the left of P, I can see that, okay, the black graph is now below the red one. The red one is up there, the black one is down there. So now this won't be part of my solution. And this would happen forever, moving to the left. The further I move to the left, this black graph is still moving down, but then the red one, it's still gonna remain above. It's gonna remain up there, right? Because of this, it's never gonna go below this asymptote, right? So this one is gonna remain up there, right? So beyond the point P, to the left of point P, my solution won't exist there. So it's between these two pink points. I need to find the x values at these pink points, right? How do I describe the x values between those 2 points? So the x value here, you see it's 3, and the value here it's 5. So my x values are between 3 and 5. So I can say that x, here, purple, x is bigger than 3, but is less than 5. Am I supposed to include 3? Let's see if we are supposed to include 3. We can't include 3, right? We can't include 3. Why? Here is the asymptote. We can't include the asymptote, right? Can we include 5? Yes, we can include 5 because they are equal at that point, right? So we can include 5. We can include 5, but we can't include 3. Now let's move on to 5.3.2. The values of x where f of x is less than 6. So remember, I told you for these types of questions, go look first for where they are equal, right? Where f of x is actually equal to 6. So f of x would be equal to 6 at this point here, right? Let me wipe these pink lines first so that we can answer the next question. So at this purple point here, f of x is 6, and at another point somewhere there, f of x would also be equal to 6, right? So I can draw a line just to show you, right? This purple line is 6, right? So this is the line y equals to 6. So they're actually asking me for which values of x is f of x below the purple line, right? So you see it's below the purple line here, and it's also below the purple line here, right? So now how do I describe these x values that correspond to this part? These x values, you can see they would be bigger than 5. So one of my solutions is actually x is bigger than 5. That's one of my solutions. One of my solutions is this one. Or x is less than the x value here. What is the x value there? How do I find it? So remember, the coordinates of this point here, D, is 5 is to 6, right? So the coordinates here are 5 is to 6, right? But remember, a parabola is symmetrical across what? Across the turning point, right? Meaning that this 3 is the midpoint of 5 and this unknown x value. I can say that this unknown x value plus 5 over 2 equals to 3. This is the midpoint formula, where 3 is the x at midpoint, where x now is the unknown value of xc, right? So I can cross multiply. I would have x plus 5 is equals to 6. Then x would be 6 minus 5, x would be 1, right? So the x coordinate here is 1 and the y coordinate is 6. So now my other solution would actually be x less than 1. That would be my other answer for this one. Then we've answered 5.3.2. Now let's wipe here. I'm gonna wipe that as well so that we don't mess our graph too much, so that we can answer the next questions. But I hope it makes sense now. Show that the equation of the parabola is that. Now this is a very straightforward question. So we have the turning point and another point, so we can find the equation of the parabola, right? We can find the equation of the parabola. So 5.4, when we have the turning point and another point, we can use the turning point formula, where y equals to a into x plus p squared plus q, right? So y would be equals to a. The value in the bracket would be negative because you see here my x value at the turning point is positive. So when I put it into the bracket, it would be negative. So we put x minus 3, right, squared, right? Q value is my y value at the turning point, that is 8, right? So now I need to find the value of a. I can substitute the other unknown point, the other known point 5 is 2, 6, right? So where I see x, I substituted with 5. Where I see y, I substituted with 6. So 6 is going to be equals to a into 5 minus 3 squared plus 8, right? Transpose the 8 to that side. This would give me negative 2. This side is equals to 5 minus 3, that's 2 squared. This is 4a. Therefore, a is equals to negative half, right? Substitute the a back into that equation, then I would have y equals to negative half into x minus 3 squared plus 8. But I need to write it in this form, so I need to simplify it. So this would be equals to negative 1 over 2 into x minus 3 squared. This is x squared minus 6x plus 3 squared, that's 9, then plus 8. Then I can distribute the half. The half goes here, it goes there, and there as well. This is going to be negative 1 over 2 x squared plus 3x minus 9 over 2 plus 8, right? So 9 over 2 plus 8, let's see how much that gives us. 9 over 2, okay, minus 9 over 2 plus 8, that's 7 over 2, right? So I can remove this 2 and replace them with 7 over 2 plus 7 over 2, and that's our final answer. It does match with the equation they wanted us to find, so we are safe. Now let's move on to the next question, 5.5. Calculate the length of M, 6 marks, right? So for us to be able to calculate the length of M, I definitely need these coordinates and also these coordinates, right? The length of MT, right? So that I can find the length of MT, I need to find the coordinates of M and the coordinates of T. How am I going to find the coordinates of M? It's the x-intercept of the parabola. How am I going to find the coordinates of T? It's the x-intercept of the hyperbola. So simplifying the two x-intercepts, right? So let's go to the next page. So remember, let's start with the parabola. So x-intercept, the y value must be 0, right? So our parabola was negative y equals to negative 1 over 2x squared plus 3x, is it 7 over 2, right? Plus 7 over 2, yeah. Plus 7 over 2. So for the x-intercept, y is 0, so 0 is equals to negative 1 over 2 x squared plus 3x plus 7 over 2, right? Then now let's find the value of x, right? Finding the value of x, we can use the quadratic formula. So, or if not the quadratic formula, I can multiply everything here by 2, multiply here by 2, multiply here by 2 as well, multiply here by 2, multiply that by 2. So 0 times 2, that's 0. Negative 1 over 2 times 2, that's negative 1. That's negative 1. X squared, 3 times 2 plus 6x. 2 cancels 2, that's 7, right? Then divide everything by that negative just to remove it. Remember, at that point, at this step, guys, you still have a choice to use the quadratic formula. I just want to make a faster step, right? Then I would have 0 equals to x squared minus 6x minus 7, right? Factorizing this, it would be x minus 7, x plus 1, right? So therefore, x is equals to 7 or x is equals to minus 1. Which one is which, right? So which one is the coordinates of M? It's going to be the minus 1, right? So the coordinates of M here would be minus 1 is to 0. Now let's go find the coordinates of T. right? The coordinates of t, it's the graph of g of x. We equate it to 0 so that we can find the x value. So for the hyperbola now, for the hyperbola, the x-intercept, we know that y equals to 0. So the equation of our hyperbola is y equals to negative 4 over x minus 3. Is it plus 8? Yeah, plus 8. So 0 would be equals to negative 4 over x minus 3 plus 8. Transpose the 8 to the other side. We have negative 8 is equals to negative 4 over x minus 3. Cross multiply. I have that negative 8 into x minus 3 is equals to negative 4. Multiply this with that. I have minus 8x. 8 times 3. Let's use our calculator. Minus 8 times minus 3. That's positive 24, right? So that's positive 24 is equals to negative 4. So minus 8x is equals to negative 4 minus 24. Then minus 8x is equals to minus 28. Divide both sides by minus 8. Right? So let's see, x is equals to 28 divided by 8, which is 7 over 2. Right? It's 7 over 2. Now let's go indicate that the coordinates here are 7 over 2 is to 0. So to find the length of MT, right, the length of MT would actually be the x value that is to the right, because this is a line on the x-axis, right? So this formula would work on lines that are horizontal or lines that are on the x-axis. So you would say that the MT is the x value that is more to the right minus the x value that is more to the left. So basically it's going to be the x value at t minus the x value at m. This would give us 7 over 2 minus the x value at m. We found it to be minus 1, right? So basically that's 7 over 2 plus 1. Let's see how much that is. 7 over 2 plus 1, that's 9 over 2, or 4,5. 4,5 units. And that's how you'd find the length of MT. Determine the equation of the tangent of F at point D. Right, so this one is a very interesting one. I'm just gonna go to the next page. So we have, I'm just particularly interested only on the parabola, right? So as you can see here, point D is this one, right? As the coordinates 5 is to 6. So let's go right. The coordinates here are 5 is to 6. So the tangent would be something that looks like this, right? And the coordinates here are 5 is to 6. Remember the function, the parabola, f of x is equals to negative 1 over 2 x squared plus 3x plus 7 over 2. And I need that. Is it 7 over 2? Just to confirm, we don't make so that we don't make mistakes. Plus 7 over 2, right? So yeah, if I want the equation of this tangent, so to apply our calculus knowledge, right? So remember that the derivative at this point, the derivative at 5 is equals to the gradient of the tangent. This is the first step of answering this question, right? So what is the derivative of f of x? The derivative of f of x would be equals to this 2 multiplied by negative half. 2 multiplied by negative half, the 2's would cancel. That would be negative 1, right? Or negative x to the power 2 minus 1, that's x to the power 1, or just x. So the derivative of this is negative x. The derivative of 3x, that's 3, right? So this is the derivative of f of x. So where is the derivative equals to 5? Sorry, where the x value is equals to 5, I need to find the derivative, which is equals to negative into 5 plus 3, right? So negative 5 plus 3, that's negative 2, right? So therefore, the gradient of the tangent is equals to negative 2, right? Because this says that the derivative of at 5 would be equals to the gradient of the tangent. Now that we found the gradient of the tangent, we found the gradient of the tangent, we can find the equation, because remember, a tangent is a straight line, right? So the equation of tangent, it's y equals to mx plus c, but we already know that m is negative 2, then x plus c. How do we find the value of c? We sub the point there, 5 is to 6. Substitute 5 is to 6. Then I would have that 6 is equals to negative 2 into 5 plus c. Then I would have 6 is equals to negative 10 plus c, right? Therefore, c would be negative, 6 plus 10, which is 16. Then therefore, plug that 16 there. Therefore, y is equals to negative 2x plus 16. Right. This is how you'd find the equation of the tangent, guys. Thank you again for watching this video, and I'll post another one for question 6.